All right, so here's another example. Use inverses to solve this system. So again, we're going to do a coefficient matrix, I matrix or X matrix, and then our B matrix. And so our A matrix is a coefficient, and then we're going to say, okay, A times X is equal to B. Find the inverse of A, multiply it by B, and when we do that, we're going to have this. And when we multiply that out, we get 8 minus 4 minus 9. And so x1 is 8, x2 is minus 4, x3 is 9. Okay, so that's pretty nice. Again, the key thing is once we have it into the form here with the a x b, then we just have to find a inverse. We know how to do that longhand. We also know how to do it in a calculator. We can get that, and then all we have to do is multiply here, and we get our values, and we get x1, x2, and x3. What about this one? Again, we're going to do the same thing. We're going to have our coefficient matrix, and then we're going to say, okay, well, now let's have a coefficient times x is equal to our b. Find A inverse, multiply it by B, and that's going to give us X. So A inverse is this, and then we take A inverse times B, and we get this, which tells us X1 is negative 6, X2 is 3, and X3 is 4. Again, just multiplying this row by the column, this row by the column, this row by the column to get our negative 6, 3, 4. All right, so in summary, using inverse methods to solve systems of equations. So if the number of equations in a system equals the number of variables and the coefficient matrix has an inverse, again, has to have an inverse or this isn't going to work, then the system will always have a unique solution that can be found by using the inverse of the coefficient matrix to solve the corresponding matrix equation. So they give us Ax equals B, we solve for X, A inverse B, that's our solution. Now, there are two cases where inverse methods will not work. The coefficient matrix is singular. You can't find an inverse. And number two, the number of variables is not the same as the number of equations. So if you have more variables than equations, then it's not going to work either. In either case, we just basically have to use Gauss-Jordan. And in the second case, where there's more variables than that, we're going to have an infinite number of solutions. And so we'll probably have to like let x4 equal some t, and maybe even eventually x2 might have to be something like s or something like that. And all the rest of the variables are in terms of those. So that's kind of what we'll have to do if those two things are the items that are found to be the case. All right, let's stop there. We'll come back for more.